are in these PowerPoint slides. But this is, okay, so Earth's moon. Is Earth's moon kind of ridiculously awesome to have a terrestrial? Is there any other terrestrial planet that has a moon like that? What other terrestrial planet does have it? What's that? Mars. Very good. How many moons does Mars have? Two. What are their names? Deimos and Phobos. Yep, Phobos and Deimos. So this is a figure from OpenStax that kind of looks then at other moons. These are moons that Galileo saw associated with Jupiter, the Galilean moons. We're going to take a look at those individually. These are some miscellaneous moons of Saturn. I'll put little check marks next to the ones that I can. Next to the ones that made it to your review sheet. Oops. What do I want to do? Pen. Okay. So the Galilean moons. Let's see. Titan. That was the one that actually was spoke of on the video too. And Enceladus is the one with geysers. What else we got?
Where's Enceladus? What planet?
Saturn, so it's the top here. Saturn, Jupiter's the Galilean moons. Uranus, I don't have any moons, although Miranda was the Death Star one. I think that is cool. I have nothing on your test. And then another moon on your test is this one, Triton. It's from Neptune. And then there's Pluto, has a large moon, Charon. And one of the cool things I didn't talk about this semester about Charon, maybe some of you already know, is it's pretty big. Charon is almost as big as the planet it orbits. Well, oops, sorry, what planet it orbits. Okay. And so because of the size, they actually, Charon makes a tug so that they orbit a common center of mass. And then Eris, which was the thing that demoted Pluto. So that's another dwarf planet out there in the Kuiper belts. So this slide kind of, I know it's small font, but this is your 4 Galilean moons, starting from closest to Jupiter going outward. So Io is kind of the odd man out. It's the yellow one. These other 3 are kind of the icy ones, and you'll see that here in a minute, or you probably saw that on the previous slide. So going outward, we have Io, Europa, Ganymede, and Callisto. I think on the video that we just watched, I think they might have mentioned Ganymede, which is the largest moon in our solar system, and maybe Europa too. So yeah, so here's Io, Europa. I think this is Ganymede and Callisto, I think. Going that way. So a little bit about Io. I like this down here, this phrase from Carl Sagan. Carl Sagan says that this particular moon, Galilean moon, looks like it needs desperately a shot of penicillin. Wow, that's pretty cool. Yeah. One of the things we talked about size. Now, Io is relatively small, but Io has got some thermal energy going on because these little pockmarks are dynamic. That's to say that actually they're like little holes that stuff oozes out of. I say ooze, it's mostly like solid particulate matter and gases. So the way it gets its heat, and actually this did make it to the test, it's a term on the test. By the way, I did record a video yesterday and post it. I'm going to put it on Twitter too, but it's on Canvas. I sent an email with the video link where I kind of do a little review session for your test. But Io's heat comes from very similar to if you've ever had one of those stress balls where they used to be in fashion where you're like, oh, I'm so stressed, and you would squeeze this ball and it would calm you down. So when you do that, the ball gets warm because you are, as it squishes this way, you're just heating it up. That motion, you're heating it up. And that's kind of what happens. It's called tidal heating. Now, tides on Earth, what creates tides on Earth? The moon, very good. And so it's a gravitational pull. So is our sun in the center of the orbits? Is the planet orbits that? It's offset. So we call it perihelion when a planet is closest to the sun, and aphelion when a planet is farthest. So also Jupiter is kind of offset. It's probably at one foci. It's kind of an elliptical orbit. So when Io is closest to Jupiter, then it gets squished out. When it's farther away, it gets kind of relaxed. So it kind of has this kind of squish out, relax, as Io orbits Jupiter. And you could go back a few slides. Was it 3 days or so? It takes Io to go around Jupiter once, so it's pretty fast. The other thing, and I think I said this in my video, is it's not just the kind of the flexing due to gravity as it gets close to Jupiter and far away from Jupiter, but it's also the presence of the other Galilean moons that kind of flex. Tidal heating. So there's Io. Got some pictures of Io. Here's kind of one part of Io. You can kind of see what I mentioned, dynamic. You can kind of see something kind of growing there.
Is that a storm?
No, it's a surface feature. It's venting from its interior. It's warm in its center. Yeah. It doesn't have plate tectonics, but it's geologically warm in there. Another image of Io, and the caption says this is kind of a composite image, but this would be places where fresh, hot lava is erupting from below the ground. So Io was not one of the places we might colonize. But the moons are awesome. We're jumping now to Callisto. And it's the outermost, but it's not the largest. Ganymede is the largest, but it's icy. The other 3 Galilean moons are kind of icy. And this is Ganymede. Ganymede, I don't probably not pronounce it. Ganymede. This is the largest moon of our solar system. And this is Europa. Europa is of interest because, as I understand it, you can kind of see these track marks where it has plate tectonics, but it's not on liquid magma. It's actually on liquid water. So, close up of Europa. Okay, so these are your 3 icy Galilean moons. Okay. We talk about rings around Saturn, but all of the gas giants have rings. Okay, so this is kind of a glance at a ring around Jupiter. Another feature that Jupiter has is this. It's called the Io Taurus. Of course, Io was the closest moon, Galilean moon that orbits Jupiter, and as it's kind of spews its gases and dust particles, it kind of leaves some debris and it kind of glows like that. Okay, so switching gears from Jupiter to Saturn. So with regard to Saturn, there's 2 moons that made the top list, and one of them is Titan and the other one is Enceladus. Okay, so Titan actually has been visited, and I think this is right. In the captions in my slides, it's Cassini. Cassini might ring some bells. Cassini was the one that took a nosedive into Saturn not that long ago. And Cassini had a rider on the way out, and it was a rover, and it landed on Titan. So the video said that there's a liquid cycle, but it's not water. The liquid cycle actually is methane or ethane, or both. So does anybody know methane or ethane? Here on Earth, what physical phase? Is it a solid, liquid, or gas? Yes. It's a gas, yeah. So what do you think? Cold temperatures slows down those little gas particles and makes them liquefy? Yeah. So, an interesting place to visit. So these are actually photographs that were taken by Huygens from the surface of Titan. And these were taken like as aerial images of Titan, drawing in some liquid of the lakes. So cool. So another moon that orbits Saturn. Saturn's got a lot more than this, but Enceladus is of interest. They call these the tiger stripes. Can you kind of see these blue tiger stripes? And that's where, from those tiger stripes, is where they've caught glimpses of geysers shooting out material from Enceladus. This is, your author kind of put this, comparing, this is Great Britain comparing to the size of Enceladus. So it's not a really big moon. So that is caught in the act, the geysers from the tiger stripes of Enceladus. And it was taken by that spacecraft that is no longer alive. But as we look for life, and when you hear, actually the NASA guy talked about this, when we look at the ingredients for life as we know it, liquid water is one of them, and here we have liquid water underneath the crust of this moon also, in addition to Europa. So it didn't make the test or anything but like that, but did Mimas, does it look like the Death Star, kind of? These are all orbiting the planet Saturn. So these are all some of Saturn's other moons. We did talk, and it didn't make it to this part, but when we talked about Saturn, remember the F ring? I said that there's a couple, I think it's Prometheus and Pandora maybe, or the F ring, which is the outermost ring of Saturn. They kind of escort, they're called the shepherd satellites. All right. And then we get to nothing with Uranus, but this is Neptune. So this is one of Neptune's moons. Uranus has moons, but I didn't pick any of those. So Miranda would have been a good one around Uranus. But Neptune has this moon called Triton. Now, one of the things I've tasked you with this semester is keeping Triton, which orbits Neptune, separate from Titan. What planet does Titan orbit? Saturn, yeah. So Triton with an O-N and an R, and Titan with an A-N and no R. Anyway, this one, the way I first learned it was this kind of strange feature, or strange kind of surface feature on Triton, calling it cantaloupe. So this is also Triton. So yeah. It's called cantaloupe terrain. I just think that is so cool. Okay. If I'm thinking of this right, and I think I am, is it on my slides? Yeah. There are definitely moons that are orbiting their planets that are not going counterclockwise, they're going clockwise. And one of the consequences of that is it's kind of a torque thing, kind of a momentum thing. But as they go clockwise around something that is spinning counterclockwise and orbiting the sun counterclockwise, they are getting ever and ever closer to their planets. So this moon around Neptune, Triton, odds are that someday it's going to get close enough to the planet. We talked about this with Mars, yeah, we talked about with Mars, that's going to get close enough that it's going to kind of break up. Probably won't fall into the atmosphere, probably break up, and it will make little chunks and make a ring. So that's
Will this create a ring around it though?
the little particles will kind of break up, yeah. Then they'll be in orbit about it. But the rings, and actually the rings of Saturn, aren't there permanently. That material's kind of in transit. And these would not be there permanently, but temporarily.
They say eventually, do they know like how many years before that happens?
How much, like for Saturn's rings to go away?
Yeah. Or no, for like this to turn into the.
I don't remember reading that. That's a good question. It's funny how things on our time scale, like 100 years is a long time on our time scale, but in terms of making a planet or a moon, it's not very long. So that's a good question. I have one more little video to show you, and then we're done.